Yeah, it's another day. Welcome to this channel as we continue with the revision. And today we are going to deal with a question on scenario analysis. This is a question on management accounting, and we shall go through it. And it says that Wangwana Growers Limited is a large-scale maize growing farm in Western region, growing maize for both domestic and export market. Fred Juma, the management accountant, has established that there is a probability of getting a high, medium or low harvest. Fred Juma has to decide on the optimum selling price for one bag of maize, and the three prices are under consideration. The selling price per bag of 90 kilograms for different types of customers is as follows. So for the wholesale price, you can sell at 5,000, retail price you can sell at 5,500, and export price you can export at 6,000. The expected number of bags of maize to sell at the three price levels for each of the above states of harvest is as shown below. So the decision alternative, selling price is either 5, 5 or 6. Condition, we can either have high harvest, medium harvest or low harvest, and the number of bags at each level that we can be able to sell. Additional information from past experience, there is a 10% probability that the harvest will be low, 30% probability that the harvest will be medium, and 60% probability that the harvest will be high. The estimated variable cost is 3 million per bag of 90 kgs of maize. The fixed cost at each selling price is 15 million. Fred Juma can engage an agricultural expert to carry out a survey on the productivity of the land, which will cost him 1 million. So required a payoff matrix table showing the net profit and the price to set to maximize the expected monetary value. So the expected, each and every time you see the word expected, just know we are using the probabilities. And advise Fred Juma whether it is worthwhile to acquire perfect information from agricultural experts. So that is the value of perfect information. So in our case, we need to start by preparing a payoff matrix showing the net profit. I'll prepare it here, payoff matrix. Okay, here's a payoff matrix showing the net profit, showing the net profit. Payoff matrix showing the net profit, and so payoff matrix table, let me include the word table, payoff matrix table showing the net profit. So our decision alternative, we are told that the expected number of bags of maize to sell at three price level. So we are deciding to sell. Fred Juma had to decide on the optimum selling price. So we need to make a decision based on price. How much are we going to sell? Which is the best alternative if we were to sell our product? Should we sell at 5? Should we sell at 5.5, or should we sell at 6? So that is our price, and we have the three levels. So we can decide to invert this, or we can just decide to use it the way it is. So whereby I will have my selling price at the top. Selling price, whereby we can either have selling price of 5, selling price of 5.5, and selling price of 6,000. And here we have the conditions. You can either have high harvest, then you have the second one is medium harvest, and then the third one is low harvest. low harvest. So leave harvest has an R harvest. Okay, harvest that way, so that we know. So the way we arrive at a profit, yeah. So the profit, if you have to find a profit is normally, profit will be equals to, selling price you minus variable cost VC, which gives you the contribution. Yeah, selling price you minus the variable cost, which gives you the contribution, and multiply by the number of units. So that's what you're supposed to do for each level. So we are selling at 5,000, and the number of units will keep on changing. Yeah, so here we shall take for the first one, I'll open the bracket. So I'll take 5,000. So my variable cost, I can put somewhere here my VC, my variable cost, my variable cost, my variable cost, which is 3,000. And you have the fixed cost. Now the our fixed cost, we have been given a fixed cost of what? The fixed cost is at 15 million. Yeah, 15 million as our fixed cost there. Fixed cost. So in our case now, yeah, so we have this, and I will adjust this formula, and I will minus at the end. I minus the fixed cost, minus the fixed cost to get now my profit. So that here I will put equals to, I will open the bracket. I'll take 5,000 as our selling price. I minus the variable cost of 3,000, and I multiply by our what? I multiply by this value. Yeah, I multiply by that our our number of units, and I will minus the fixed cost here of 15, whereby you'll find that in this one they can decide to lock these. Okay, so I'll see what will happen to that. I'll put equals, so that will be our, let me use the 1,000 separator there. Yeah, 11 million is what we are getting there. Let me see if I drag this, whether it will give us the answer. Okay, so P7, so that one is not okay. So this one will be equals to 5, and I minus the variable cost. We multiply by our units, which are now 10,000, and I minus my fixed cost. We can decide to lock. The selling price is fixed in this case. I lock this, and I lock this. Yeah, still it will give you the same answer. 15 million. I'll get 5, and for this one I'll take 5. I minus 3. I'll close that bracket, multiplied by the number of units, which is 6, and I minus my fixed cost here. Yeah, so I'll get negative. You can still format that. So let me format this. Yeah, that way. So that is the lowest. When we come to this other, now I will open the bracket. So 5 I minus the 3000. I close the bracket. I multiply by the number of units here, and I will minus my fixed cost. And the second one will be selling price. I minus the variable. I close. I multiply by the units, which is 9, and I'll minus my fixed cost. And the next will be my selling price, and I minus my variable, and I close that. I multiply by what? The units, and I minus my fixed cost. Yeah, you get a 0 there. The next one, I'll start with this. My selling price, I minus my variable, and multiply by the number of units, and I minus my fixed cost. That way. Let's see if we lock this. If we lock that, if we lock this, and if we lock this, yeah, that way. And I will enter that. Let me see if I drag this whether it will pick. Yeah, I think it has picked that. Just see, just pick us like this one. So multiplied by H18. Yeah, H18 is this one. So both of them are the same. That's why it's the same. Yeah. And for this one, H19. Yeah, that one is okay again. Just picked this because this is the only variable that is changing, and that is our payoff. That's our payoff table. Yeah, our payoff table was looking something like that. Payoff matrix showing the net profit for the 3 scenarios that. Then the second question, that was the first question. That was Roman 1. Roman 1. Roman 2, they need us to do what? The price is at the price to be set to maximize the expected monetary value. Remember, we had the probability. If I can include my probability here, my probability. So the first one was 10% for the lowest. Yeah, low is 10% here. Yes, it's 10%. And this other one was what? 10, 30 for medium, 30%. And the other one was 60%. 60% as our probability. Yeah, for the 3 states. So you need now to determine the price to set to maximize the expected monetary. Yeah, so at 5,000, at a price of 5,000, so we shall have our EMV. Our EMV at 5,000. EMV is expected monetary value. So this will be, I will open the bracket. I do using brackets. I'll take this, I multiply by my probability, and I add, open the bracket, this one multiplied by the probability, close the bracket, and I add, open the bracket, this one multiplied by the probability, and I close the bracket and I enter. So we shall have that for the first. Then at 5,500, so it will not pick that, so I'll just do it again directly. It will be this one, and I multiply by this one. I close the bracket, I add, open the bracket, this one multiplied by the probability, and I add, open the bracket, 0, and I multiply by this one. I close the bracket and I enter. Then at 6,000, our EMV, we will open the bracket and have this multiplied by the probability, and I will add, I will open the bracket, this one multiplied by the probability, and I will add this one multiplied by, so I will open the bracket, this one multiplied by the probability, and I enter. That way, we use 1,000 separator so that you can be able to see that. Yeah, that way you can set a selling price of 5,000. So this is selling price, this is selling price, and our EMV, selling price and EMV. So at a selling price of okay, let me eliminate this. No, even this one, yeah, that way, so that I can expand this. Yeah, that way. That's our selling price, and this is our EMV that we have. Okay. Just a minute, just, yeah, that way. So that now at selling price of 5, the EMV is 78, selling price of 5, the EMV is 12, selling price of 6 is 9. So the best, we were asked the price to be set to maximize the expected. If we are to maximize the profit, our advisor will be, they should set a selling price of what? Selling price of shillings 5,500. That is one that maximizes profit at 12,000. Then we go to Roman 3. Yeah, Roman 3, and for the Roman 3, they need us to find what? Advise Fred Juma whether it is worthwhile to acquire perfect information from the agriculture. So we are told that Fred Juma can engage an agricultural expert to carry out survey on the productivity of the land, which will cost him what? 1 million. So expected value. So here we need the value of perfect information. Yeah, expected value of perfect information. And expected value of perfect information is normally equals to EMV with perfect EMV with perfect information, and we minus EMV without perfect information. Yeah, EMV with perfect information, and we minus EMV without perfect information. So whatever we have here is EMV without. This 12 is EMV without. So we can find EMV with perfect information, EMV with perfect information, So if we are to find EMV with perfect information, we normally start with we are looking at now the state where we have high, we have medium, and we have low. So if we are certain that we shall have high harvest, we select the one that will give us the maximum, and the maximum will be 16 to 50 and 55. So here we shall take this and multiply by the probability there. Then under medium, the highest will be 10, so we take the highest, payoff by the probability. Yeah, if we know it will be medium, we shall export, and if we know that it will be low, then the base will be 0. It will be 0. Yeah, and you add that alt equals and you enter, so that way. And I will bold this, I will put the top border, can use both top and bottom border. So this will be our EMV with the perfect information, and let me remove that. So EMV with the perfect information will be that way, and I will minus here EMV without no border, so that I just put the top EMV without EMV without. So without perfect information, already we had it here. This one without perfect, it will be 12.9, and I will minus this, I will minus that, so that the value of perfect, expected value of perfect information will be alt equals for the two of them, the sum of the two, this one. So value of perfect information will be 9,900, yeah, so it will be 900,000. And remember now the cost they are charging us what? Fred Juma can engage an agricultural expert to carry out the survey, so it will cost us 1 million, but what we are getting as the value is 900. The maximum that we should pay is 900. So advise Fred Juma whether it will be worthwhile to acquire the perfect. It will not be worthwhile, because the cost of acquiring it will be more than the benefit that we are getting of 900. So acquiring this perfect information will give us 900 as the maximum benefit, but we shall pay 1 million, so it's not worthwhile. So our advice, we shall say it is not worthwhile. It's not worthwhile to acquire the perfect information, because it is expensive, expensive to acquire. It's expensive to acquire, where we shall say the maximum amount to pay, the maximum amount to pay should be 900,000. That is the maximum that we shall be willing to pay, 900,000. Anything upward of 900,000, then it will not be worthwhile for us to acquire that particular perfect information. And that's how that question was supposed to be done, as far as scenario analysis, whereby we are having 3 different prices or decision alternatives, and we need to make a decision and advise this person, Fred Juma, on the best price to use, and we have prepared our payoff table, and we have been able to find the best price that they should be able to set, using the EMV, expected monetary value. And we have also been able to find, to advise them whether they should engage the services of an agricultural expert in order to enable them to make the maximum profit when we use the work of an expert. By the end of the day, we have seen it will be expensive. We shall not be able to benefit from the work of the expert because of the net expected value that you are getting from the perfect information. And that's all. Continue subscribing to this channel for more revision on business data analysis.